welcome back to Daily Does of Space. Today, we're piecing together a new story about our universe, one built from two seemingly separate discoveries that are, in fact, profoundly connected. Because while one telescope has caught our entire galaxy, moving in a way we never imagined, another is finding planets that break every rule of how worlds are born. And when you put them together, a startling picture emerges, a universe far more dynamic, chaotic, and alive than the static cosmos we once believed in. This is that story. The rippling galaxy. Imagine viewing the Milky Way, not from within, but from a distant godlike perspective. What should be a calm, flat spiral of stars is instead gently rising and falling, a vast, slow-motion undulation as if the galaxy itself is breathing. This isn't science fiction. It's the landmark discovery from the Gaia Space Observatory. Gaia has been charting the precise positions and motions of over 1 billion stars. By comparing this data across years, astronomers saw a pattern. Colossal sections of the galactic disk aren't just orbiting the center. They are moving vertically in a coordinated wave. Stars in one region lift upward, in another, they flow downward. This galactic ripple spans tens of thousands of light years. No standard model predicted this. A calm, settled galaxy shouldn't behave this way. So, what could set a structure of 200 billion stars into such a coherent, ringing motion? A collision with another galaxy. The leading theory points to a past collision. Our Milky Way has a small disruptive neighbor, the Sagittarius dwarf galaxy, which has likely plunged through our galactic plane multiple times. Each pass is like dropping a stone into a pond, gravitationally tugging at the disk and setting off oscillations that may take eons to fade. We could simply be seeing the Milky Way still ringing from an ancient impact. The spiral arm echo. Another idea looks inward. The galaxy's majestic spiral arms are not fixed structures, but density waves, cosmic traffic jams that stars move through. As these patterns shift, they might generate secondary echoes, creating vertical waves in the disk. While mathematically plausible, this struggled to explain the sheer scale of the undulation Gaia has observed. The dark matter impact. Hypothesis 3. The dark matter impact, 12 to 14 minutes. The most dramatic possibility involves the invisible scaffolding of the cosmos. What if the Milky Way was struck not by a visible galaxy, but by a massive, dense clump of dark matter? Invisible and intangible, it could have passed through us like a ghost, its immense gravity delivering a powerful kick to the stars in its wake. If true, the wave we see is the galaxy ringing like a bell struck by an unseen hammer, and we are living inside that lingering vibration. Planets that defy time. While Gaia maps the grand architecture of the galaxy, the James Webb Space Telescope, JWST, peers into the cradles of planet birth, the swirling disks of gas and dust around infant stars. What it has found is shattering the textbook. JWST has observed young star systems only a few million years old that already host fully formed gas giants the size of Jupiter. According to the dominant core accretion theory, such planets need 5 to 10 million years to slowly build up from dust grains. Their existence isn't just surprising, it's impossible on that timeline. This is not a lone anomaly. JWST is revealing a catalog of rule breakers. Gas giants forming almost instantaneously. Planets locked in bizarre, wildly tilted orbits. Planetary embryos surviving in regions where they should be torn apart. Mini Neptunes and warm Jupiters appearing in disks too thin and young to host them. The classical, slow and steady model is failing. Astronomers are now forced to consider a more violent, rapid mechanism. Gravitational instability, the cosmic collapse. Imagine a planet not built piece by piece, but born in a single dramatic event. In this model, a local region of a massive protoplanetary disk becomes so dense and unstable that it directly collapses under its own gravity. In a cosmic blink, years, not millions, a gas giant is born. It's like a bubble forming and instantly taking shape in a boiling pot, rather than a snowball rolling slowly downhill. This process naturally explains fast-forming giants and their potential for chaotic, misaligned orbits. And when we reconnect this with the Milky Way's Great Wave, the story becomes truly compelling. The cosmic choreography. What if the galaxy's motion and the birth of planets are part of a single dance? If the Milky Way is rippling, then the vast reservoirs of gas between the stars are also being rhythmically compressed and rarefied. Density is the trigger for star and planet formation. Picture this. As the galactic wave passes through a region, it squeezes the interstellar gas. This increases local density, which boosts gravity, which accelerates collapse. In these triggered high-density environments, the conditions for gravitational instability become perfect. Planets could form not just faster, but in greater numbers and with more wild diversity. The ripple from an ancient dark matter encounter or a galactic collision could thus directly influence where and how planetary systems are born billions of years later. It's a cosmic chain reaction linking the invisible tug of dark matter, the grand ringing structure of a galaxy, the violent, rapid collapse of planetary nurseries, the final architecture of alien solar systems. We are seeing a galaxy not as a static backdrop, but as an active, shaping force. The old view of a serene clockwork cosmos is fading. We now see a Milky Way that is dynamic and trembling, shaped by ancient violence. And within this vibrant, oscillating environment, planets are born in ways that defy our old, slow-paced theories. We are on the brink of rewriting the story of how planetary systems, including perhaps our own, come to be. The universe is proving to be more turbulent, more interconnected, and more astonishingly alive than we ever dreamed. If you enjoyed this journey to the edge of cosmic understanding, subscribe for more deep dives into the discoveries reshaping our place in the universe. Thanks for watching, and see you in the next one.